Hi, I'm Sampo Pyysalo, and I'm happy to have the opportunity to present our work on fine-grained named entity annotation for Finnish. So a few words of background to start with. As I'm sure you well know, named entity recognition is a key task in natural language processing. And despite recent advances in cross-lingual transfer, state-of-the-art NER systems still require target language training data. For Finnish, existing NER annotations use a comparatively coarse-grained representation and a custom type scheme that's not compatible with any used in languages other than Finnish. In this work, we introduce fine-grained NER annotation for Finnish using the established ontonotes representation. We combine, revise, and extend two existing corpora, producing a resource of nearly 500,000 tokens, annotated for over 50,000 mentions. We show that the annotation allows highly accurate tagging at 93% F-score using a BERT-based NER system. Finally, we demonstrate compatibility with ontonotes NER annotation in cross-lingual experiments. This table here presents a summary of the statistics of our data. So we use three corpora in this work. Ontonotes, the large, multilingual, multi-genre corpus with several annotation layers, of which we only use the NER annotation. Second, finer, a Finnish NER corpus that consists primarily of technology news, with a Wikipedia out-of-domain test set, annotated using custom named entity types. And third, the Turku NER corpus, which consists of the Turku dependency tree bank corpus texts, a multi-genre corpus, and these annotated similarly as finer. First, a few words about Annotation Schemata. So the two Finnish corpora annotate six types: person, organization, and location, familiar types from the Conal tasks, as well as product, event, and date. By contrast, ontonotes covers in total 18 types, summarized on the table on the right. We note that the existing annotations for person, event, and date can mostly be directly mapped to ontonotes types one-to-one. By contrast, organization, location, and product require more complex mapping, where a single type in the source data may be mapped to more than one type in the ontonotes representation. We also note that most of the ontonotes types are not annotated in the existing two corpora for Finnish. In addition to the type differences, the existing Finnish NER corpora apply a scheme where annotation spans must start and end at syntactic word boundaries. So this is a bit of an issue because Finnish hyphenated compounds can involve a name as part. For example, a fan of Finland, Suomi-fani, Nokia-puhelin, a Nokia phone, and Pekka-niminen mies, a man named Pekka. In the two existing corpora, the words Suomi-fani, Nokia-puhelin, and Pekka-niminen were annotated either as a whole or not at all, according to specific rules set out by the finer guidelines. In this work, we introduce fine-grained tokenization that allows names to be annotated also when they occur as part of hyphenated compounds. We introduce the ontonote-style entity annotation for Finnish using the existing annotations in the following steps. First, the person, event, and date annotations are mapped across as is, only modifying the type names. Second, the location, organization, and product annotations are mapped to their appropriate types using heuristics that are based on form and tag. For types that are not in scope of the existing annotation, such as languages and nationalities, initial annotation was introduced using dictionary-based tagging. Finally, initial annotation for numeric types targeted in Ontonotes was produced by mapping universal dependencies annotations, which were manually created for the Turku-NER corpus and automatically annotated for finer. To map the finer style syntactic word level annotation to the fine-grained tokenization, we introduced a set of custom scripts using manually written affix heuristics. So for example, the expression Nokia puhelin tagged as a whole as a product, where puhelin is phone, is mapped to an annotation where only Nokia, the name of the product itself, is annotated. We use dictionary tagging together with corpus-level consistency checking to assure that mentions that were not annotated by the finer guidelines were also marked. For example, Nokia kokemus, experience in Nokia, was mapped to annotate also the mention Nokia appearing as part of the hyphenated compound. Here are some additional examples of the conditional mapping. So we see that, for example, the location type in the source corpora can map to the GPE, geopolitical entity type, when the annotated mention is a country, such as Finland, or to the location type when it's, for example, the Mediterranean. The product type in the source corpora can map to either product in terms of Ontonotes types or to work of art when it refers to, for example, a book. After initial heuristic mapping and the dictionary-based tagging, we assured the consistency and correctness of the annotations by checking them in a series of semi-automatic rounds of revision. After the initial annotation, we noted that the finer and Turku-NER corpora contained very few mentions of laws, one of the Ontonotes types. So this lack of examples could cause a failure to learn and an inability to evaluate the tagging of law entity mentions. To address this issue, we augmented the corpus with a random selection of 60 documents from current acts and decrees of Finnish Acts of Parliament. These total approximately 24,000 tokens. And these texts were annotated following the same process as the primary corpora. Here are the statistics of the resulting annotation. So the combined extended corpus contains nearly 500,000 tokens. Half of these have at least 1,000 annotated mentions in the data, with the most frequent type for organization tagged in over 10,000 mentions. Even for the rarest type, facility, there are over 200 mentions. The manual revision steps were performed by a single annotator, which makes it impossible for us to do standard inter-annotator agreement for this annotation quality. Instead, to assess the internal consistency as well as the compatibility of the annotation with the Ontonotes corpus, we performed a series of machine learning experiments. All of these experiments use the BERT-based NER tagger that Turku NLP has introduced previously, varying the data and the BERT model that we used as a starting point for fine-tuning the model. We used the train, devel, and test splits of the existing corpora, splitting the new texts from the laws chronologically. In our experiments, we apply the following 4 BERT models: the original BERT for English, FinBERT for Finnish, multilingual BERT for experiments in both, as well as a bilingual Finnish-English model introduced by Turku NLP previously. So the monolingual models are just used for their respective languages, whereas the bilingual capable models are also used in cross-lingual and multilingual experiments. As for our experimental setup, we select hyperparameters conventionally using a grid search, using a range of parameters, adapting the one suggested by the authors who introduced BERT. The parameter values are shown here. Performance is reported using standard precision, recall, and F-score using the Conditional eval script matching criteria. And of course, the test data is held out during parameter selection and only used to evaluate performance of the fine-tuned models. Here are our monolingual results. For English, we find performance that's broadly comparable with recent BERT-based taggers for the same corpus. For example, one author recently reporting 89.2% as opposed to our 88.7%. For Finnish, we find performance only slightly below that we previously reported for the combination of the two corpora, where they only had the coarse-grained 6 types. So we lose about 0.7% in extending to the much more finer-grained ontonotes types. These results suggest the conclusion that the newly introduced data has high internal consistency. For bilingual models, we train on the combination of the ontonotes English named entity annotations and the newly introduced corpus, so a naive catenation of texts in 2 different languages. And we find that the BiBERT model outperforms the multilingual BERT on both languages. For Finnish, losing just 0.2 percentage points as compared to our monolingual result. And surprisingly, for English, the bilingual model outperforms the monolingual by 0.5 percentage point. These results indicate that the newly introduced data is highly compatible with ontonotes English named entity annotation. Finally, we tested zero-shot cross-lingual transfer, training on the ontonotes English named entity annotations and testing on the newly introduced Finnish corpus. The results here are not spectacular. We again find that the BiBERT model outperforms mBERT, and while performance is notably below that of a model which has target language training data, it's not catastrophically poor at slightly below 80% F-score. These results for zero-shot evaluations suggest that zero-shot tagging could be considered to bootstrap ontonote-style annotation for a language that lacks this type of resource previously. In conclusion, in this work, we introduced fine-grained ontonotes-compatible named entity annotation for Finnish. We combined and extended 2 existing corpora for Finnish in the resulting extended mapped combined data, marking over 50,000 mentions in documents of nearly 500,000 tokens. Experiments using a BERT-based tagger showed that the corpus allows highly accurate tagging of the 18 fine-grained ontonotes types. And as always, the corpus is available under an open license from this Turku NLP URL. Our thanks for the Academy of Finland for their support of this work, to CSC, the IT Center for Science Finland, for computational resources, and thanks to you for watching.